Hello, everyone. My name is Xisco Fauli, and today I'm going to talk about UI testing in LibreOffice. First off, thanks to col.la and Miklos for inviting me to give this talk. And I've been working for the Document Foundation for the last 8 or 9 years, I think. Yeah, 8 years. And I focus mostly in QA. So yeah, a bit of introduction. The UI testing was implemented back in 2016 by Marcus Morhan. It consists of two parts. The first one, is the CPP introspection library, which is a interface that communicates mostly, or does the communication mostly with string parameters. And then, you can find
Record
more.
is on.
Oh, the recording is again being done.
The
Hello?
recording, yeah, the recording was on. I don't know what was that. Maybe some issue, some glitch.
Should I start over or?
No, I think you can continue.
Okay. So I was saying that you can find most of the code in the files that are called UI object, and also inside BCL UI test. And on the other hand, we have the Python framework, or yeah, which inherits from the Python unit test, and it's where all the tests are written. So the tests are written in Python, and uh, the framework can be found in UI test folder. And then for the test, you just have to go to each module inside QA. There is a folder called UI test for that. So for instance, for writer, the UI tests are in SW QA UI test. Some limitations that we have with the UI test framework is that it doesn't work on macOS, or at least I'm not aware that it works. Maybe I've never tried it, but maybe someone have tried it and it works. But so far, I don't think it works. Then on Windows, it works, but it's not enabled by default in the CI. So if there is a new test that doesn't work on Windows, we are not going to catch that failure unless then someone, like, I believe Mike Kagansky sometimes runs them on Windows, so then we are aware there is a failure. And then on Linux, they work, but they use by default the Gen environment. So if we want to test something specific to KDE or to GTK, then it doesn't work. And yeah, then another thing to mention that in general, they are slower than CPP unit test. So when we are going to write a UI test, we have to wonder which, the purpose of the test. If it's going to test the UI, then it makes sense. Otherwise, if, for instance, we are going to test the content of the document, or doing some import export testing, then it makes much more sense to test it in CPP unit test. Then other limitations to mention a few. There are a few more. It doesn't support base, and the reason is that the code is in Java. And also there are some dialogues in the menu file wizards, which are not well, so then it's not supported by the UI testing. So yeah, in order to write a UI test, then we have to create a make file. So for that, this is a sample of here of how to do it. It's really simple. In general, they are just the same, just a few things that we have to change. Well, here's um, the name of the target. Then here we just say where the tests are going to be placed. So in this case, every document, every Python document that we put inside this sort folder is going to be executed. And finally, we have to define this tdoc variable, which is basically if we need to open a document with the UI test, then where these documents are going to be. Something to mention is that by default, the UI tests are executed with one process, meaning that all the tests that are inside the target of the make file are going to be executed with the same process. Before, we had different processes, or a new process was created for or every time that LibreOffice was executed, but it was much slower, so it was changed to just execute all the tests in one process. So meaning that it's going to be faster, but it can be problematic because there might be tests that affect other tests that are going to be executed after that one. So in that case, we have to make sure that after we what the test is, it's done, it's finished. The previous status is well, the changes that we do in that test are not going to affect other tests. For instance, if we in one test we go to options and we change one of the LibreOffice options, then the following tests are going to have that option as well. And in case we want to avoid this one process enabled by default, we have to use avoid one process. Yeah, so by default, the UI tests are run in headless mode. So basically, if we want to run it, for instance, for the sort, you just call make. But then if we want to call a specific UI test, we can pass the UI test name. So then only one test is going to be executed. Then there is another way. A good thing of the UI test is that you can execute it in yeah, you can visually see the test running. So for instance, I can execute this test here. So if I copy here this and executed it, we're gonna see that the test is executed in live. So this is, oh, I don't know if you can see it. Yeah, here. So this is really valuable because you know what's going on in the test. And then, well, you have more information on how to run the test here in this URL. And finally, another thing that I find very valuable is that you can also execute the UI test with the bisect repositories. So here I share the script that I use to do so. It's already in the wiki. But yeah, it's really worth to do it because you can, I mean, if you want to write a UI test for existing fix, you don't have to revert it in your local page. You just have to go to the bisect repository, go to the commit where the issue was fixed, run it there, see it passes, and then just move one commit before, run it again, and see if it fails or not. So it's really straightforward to yeah, to work with this kind of test. Well, another useful tool that it's implemented in LibreOffice, it's the UI logger. So basically, you just execute this command here, And for instance, this is the output that you get when you run writer, and then you go to, if you see you writer, then you go to insert a table. Then in here there is this element which is the table name. So you basically just change it, and then well, you close the dialog, and basically you create a table with 2 rows and 2 columns. This is very useful because you can get the commands that you are executing, and then you just have to translate it into the test and into Python, and it's quite straightforward, very helpful. Yeah, and let's have an example here. This is an example that basically implements what we have logged before. It's the same example as creating a new table. So basically, we just go to the Start Center and open Writer. Then we execute the dialog, insert table. Then we get the child, which is called name edit, and then basically we select all in that element, and we change, or we type test. Then we execute the action up for the column spin element, and then we do the same for the row spin element. And then we also assert here that we have the correct information on the dialog. And once we close the insert table dialog, which is here, then on the document we can see that we have already a table which name is test, that we changed before, and the name of the number of columns and rows that we have in the document. And yeah, some important or useful prints that you can use when we have a dialog. We can get all the children that the dialog has. So for instance, this is the insert table dialog, and here we can see some of the elements that we used before, like the col spin or some others. So depending on what we want to use or assert, we can look for those children there, for the elements there. And also for every element in the dialog, we can use this method, which is get a status dictionary. So basically, we get all the states of the element. Yeah. So for instance, in this case, we have that this element, the property text is test, and some other information that we can assert in the test. So yeah, as now I'm going to give some examples that things that can be done with UI test. So yeah, basically as mentioned before, create doc in a Star Center. We can use different parameters like writer, calc, impress, or draw, for instance. And yeah, this is the way to create an empty document for those elements. Then if we want to test an existing document, you can use get URL for data file in order to do so. And then we already opened the document. Yeah, this is the same example I gave before. When we want to open a normal dialog, we just execute the dialog through command, and this is the only command that we need to pass. Yeah, and in some cases, some of the dialogs are modeless. So in that case, we will have to use the execute modeless dialog through command. And by default, there is also this close button, because as we see, when we call these methods, they are within a with statement. So this means that once we are done with the dialog, this method will close the dialog automatically, and by default it uses the OK button. But in this case, because we want to use the close button, which has a different ID, then we can specify which close button we want to use here. Yeah, and in some other cases, using the load method that I described before doesn't work. So in that case, we have to go through the open dialog. So in order to do so, here is an example on how to do it. So basically, we just open the open document, and then we look for the file name element, and then in here we type the name of the document, and then basically here we click the open document and we wait until the document is loaded. Yeah, and same for save a document and reload it. In this case, what we are going to do is to call the save as dialog, and here we specify the name of the document and once it's saved, because, well, basically we are using a temporary directory. So once it's saved, we open it again with the low file that I described before. Yeah, this is something that also can be done. We can work with different documents at the same time, and in order to do so, we basically have to use the get frames. So depending on which frame we want to work with, we will have to use one or the other. Yeah, and same. In some cases, there are some issues. For instance, you have to copy some text in Writer and then paste it in Calc, and then once in Calc, you have to check something. So that's something that can be also done in UI testing. So basically, what we will do is to open Calc, do whatever we have to do. Let's say we have to copy some content, and then we go to Writer and we paste it and basically check that everything is as expected. Yeah, another thing that we can also test in UI testing is basically the sidebar. So in this case, right, we are using Writer. So we call the command sidebar, and then we execute the action to display the inspector text panel. Yeah, so basically there are different panels in the sidebar. So in this case, we want to open this one. So basically, we just pass it here as a parameter to the as an action to the sidebar. And yeah, once we are done, we just have to close it, and that's it. And yeah, same for the navigator. The navigator works as a part of the sidebar as well, so we just have to do it here. Sometimes, because there are asynchronous calls, we will have to use wait until child is available. So in this case, once we launch the navigator panel, we wait until the navigator panel it's available, and then we can already work with it. Yeah, this is also if we want to work with forms, kind of the same issue. Sometimes, well, if yeah, we have to wait until and make sure once we execute the control properties. So when you have a form and you want to check the control properties of this form, yeah, this seems it's called asynchronously. So then you just have to wait until child is available. So then, yeah, you otherwise you make it a failure. Yeah, same here. Page break. Well, kind of the same. So you execute insert page break, then you wait until the page break, that is this element here, it's available, and when it's available, you can execute the dialog through an action, which basically the action is to edit the page break. Yeah, this is something that we didn't have test before for this, so it's really handy to have this with the UI test. Now we have a lot of auto filter tests. So yeah, basically we just get the grid window element, and then we execute or we launch the auto filter, which is in this case on the column 0 and row 0. So once we do it, we get the floating windows, which is this one. There are some different elements in LibreOffice which are floating windows, well, a few, but this is one of them. And once we get that element, then we can get the child, which in this case, this filter drawdown, it's this part of here. So yeah, and then check tree box is this, well, is this part, the check tree box, and then we are getting the first element. So yeah, this is another way of using of checking out the filters. And yeah, also for charts, in this case, we are opening the calc document, and then we are selecting this object one, which in this case is the chart of the document. Then we activate it, and after that, we yeah, we get the top focus windows. So once we yeah, we activate it, and now the focus is on the chart. So now we can, depending on the element of the chart that we want to check, or because depending on what's selected in the chart, let's say if the bars are selected, then one document will be open, and if another element like the labels or the title are selected, then different dialog will be open. So depending on this element, then we can execute the command, and then for instance, in this case, we are opening the format J error bars dialog. And yeah, these were some examples of how to use UI test. And in case there is an element that is not supported, here's an example. So basically, what we have to do is add the method get UI test factory to the element. In this case, we are using the calc grid window, and then we just call create of the UI of object. Then we have to create a UI object headers, which normally looks like this. For instance, well, this is the execute that I just mentioned. But for instance, get the state is the same. Well, it's the method that is executed when we call from Python get the state as dictionary. And yeah, and execute is the same when we, for instance, let me see. Yeah, for instance, when we do execute action activate, it means that in here there is a part that handles the activate code. So here's an example of the dictionary that we create for the stage. Yeah, so basically, for instance, if we want to know which is the selected table, we just add the ID to the map, and then we just, in this case, for instance, is the table number, and yeah, current column or current row. So then we can use these elements in Python to assert the stage of the element. And yeah, this is what I mentioned when we execute. Well, when we call execute, for instance, this is the part an example that is handling the select action. So yeah, basically, if we use select as an action, then we can pass the parameter extend, and then, well, so on. Then depending on what we want to do, then we will have to do it in this part of the code. And here there are some links that I found interesting. Yeah, one is duplicated, but yeah, basically most of the information is in the wiki and the UI test, and I added a couple of blog posts from Marcus that he wrote, but back in the day when he implemented the UI testing, and they are really interesting. So if you want to know more information about UI testing, go there. And yeah, that's basically all from me. Do you have any questions?
Thank you, Cisco. So, questions, tips?
I
Okay.
have a question.
Yes, please, Ash.
Hey, Cisco, thank you for doing this. In your experience, has there been random failures because of timing? Maybe the UI wasn't ready by the time that some input was in the test, so that kind of uh, you know messed up the state, and so the test fails simply because uh, there was some delay somewhere. But if you run it again, it works. Have you seen cases like that? I'm just curious.
Yeah, there are cases like that, and sometimes we have sporadic failures on CI as well, which may also be caused by this. So the way that we have tried to deal with these problems is just to use this, as I mentioned before. Where is it? Yeah. For instance, here you have the wait until child is available. So the problem is that in this case, for instance, yeah, when you execute the insert page break, probably when you want to look for this child, maybe it's not available. So maybe we have to wait a bit of time. So that's the way the UI test is trying to deal with these issues.
Makes sense. And can we do this for all expected UI elements and updates before we proceed, or are there cases that we just we have to do a sleep or something crude like that?
So I don't think, maybe I've seen few tests where a sleep is needed, but the way this method works is just checking every half of a second or even every shorter time if the element is already, or if the child is already available. So it's kind of a sleep, but just checking it in a while through loop. But in general, these kind of things are not necessary, just are needed in a specific cases. So it's not like you have to use wait until child is available all the time. It's just when we have found that, okay, this is something is going on, something is problematic. Sometimes the issue is reproducible, so sometimes not. Okay, let's try this. But in a normal UI test, you shouldn't, like, let's say the one I mentioned, that okay, you go to the insert table dialog, which is a simple one, then you are not, you don't need to use this wait until child methods.
Makes sense. Yeah, thank you.
Thank you, Ash. Hussein, questions?
Yes. Cisco, thank you. I have some questions. First is that I usually run UI tests with internal Python, but is it usable with system Python also?
I don't know. I have no
Okay.
idea.
So my second question, you have mentioned the asynchronous methods that start with waits underlined. So is it the case for each and every asynchronous method? Are they usually start with wait something?
Well,
Yeah.
think so. As I said, we just use this wait underscore methods when it's necessary. So it's normally they are not used. So I don't know if that answers your question.
Okay, fine for now. And my last question. Uh, the UI test framework provides a nice API to work with the UI. I was wondering, on the other hand, the Uno API itself provides some methods to work with LibreOffice process and UI, and it's also available in Python. So, are there things that not available in the Uno API? So do you recommend, for example, if I want to manipulate documents, create documents, that I use UI test framework for doing that? Let's say doing things beyond testing with this framework.
Um, I don't know. I can like. Do you have an example of any usage you could?
Yes, for example, if you look into the dev guide, you can see that with Python, someone can create documents and, for example, write something in the document and draw shapes and things like that. But I want to, let's say, ask the UI test seems to provide, let's say, more functionality compared to the Uno API itself. I assume because you can work with the dialogues, things like that. So I think my question is, do you recommend using the UI test API for things beyond what is available in Uno API?
So, well, basically the purpose of the creation of this framework was just to test the UI, meaning that if you can already do with the normal API, you can already do whatever you want to do. Then what do you need? I mean, why do you need to open the UI or any dialogue if you can already do it through API with Python?
Because something might not be available in the Uno API directly.
Okay. Yeah, maybe it makes sense. I don't know.
Okay, thank you.
Thank you, Hussein. Kellen, do you want to add something?
Well, I just mentioned on the chat about for the case of Cypress tests, which we have problems with all the time. We search for buttons and we have to wait and come back and try a few times automatically as part of what Cypress does for the button to show up. Whereas these tests, because they are inside LibreOffice and we have access to the internals there, we can do extra things like this process events to idle, so we can just wait and know that the queue of events to launch buttons or etc have all been processed, and then we can see if the button has showed up. So we avoid the Cypress style waits because we have a little bit more insight into when the button, as to what is being processed by the core in advance of the button being showed up. So it's not exactly the same. Otherwise, as in Xisco, do we have any idea of the kind of coverage of dialogues that are covered? Have we any way of finding out if we have 50%, 80% of dialogues covered by tests?
Yeah, that's a good question, but I don't have that information. Yeah, that maybe there's something that we should check to see what's the coverage. Actually, I wanted to, I mean, it's not an answer, but I wanted to check the number of UI tests that we have, and I forgot to add it to the slides. But yeah, that's something that I try to see what coverage we have.
That's all I got.
Okay, thank you, Kellen. Jaume, questions? Andras, questions?
No, thanks.
Attila?
No, thank you.
Miklos?
Yes, I would have one.
Mhm.
Xisco, you mentioned that the Python tasks are more like Python UI tasks are out of process, and obviously that has this benefit that you can cheat when you do bisecting, and that's nice. On the other hand, when a task is failing and all you have is just the just created installation, and this is failing, then it's a bit painful to debug because you need to work with two processes, the Python one and the Sophis process, and like it's just harder to debug compared to CPP unit tests. So do you know what is the reason that we have this setup, that they are executed out of process, or that was like way before your time and Marcus decided this is the way to go, and we just stick with that because it's not painful enough to even explore other things? Or
So if I know why the UI test is going out of process, I have no idea. Sorry.
no, that's a fair enough answer. I can imagine that there were a few approaches tried, and perhaps Marcus had some design decision there, but it was it's a bit unclear to me. But
Yeah, there is in the in here in the blog post that I mentioned that were written by Marcus. There are some explanations why this design was chosen.
Okay, thanks.
Thank you, Miklos, for the question. Next is Bayram. Questions? Okay, Aaron.
No question, thanks.
Thank you. Cosmin? No questions. Darshan? Okay, Ezine, questions?
No questions from me. Thank you.
Okay, Hussein?
Yes, just a quick question. Cisco, is all the UI test framework implemented on top of Uno API?
I don't know. Yeah, I believe so. Yeah, it's basically it's using this CPP. What is it? This CPP introspection library to communicate with the Juno API.
Okay, thank you.
Thank you, Hussein. Next is Gulsha. Questions? Okay, I guess no. João? Okay, Mevan? Rash? Okay, Kellen, is there something else you want to add, or?
No, nothing at all.
Okay, thank you, everyone. Thank you, Xisco, for the presentation. I will see you next week.
Thank you very much.